Okay guys, so in this video we are going to have a look at message queues, so let's get into it. So what we're basically going to cover is what is a message queue, what are their use case, and well, an example use case. Yeah, that's pretty much it really. So a message queue or message queues, they are just a storage system, or you can think of it as a distribution channel for publishing and subscribing to messages. Now, what does that mean? Well, the simple answer is that a message queue is just an application where you connect to it, to just like you would connect to an HTTP server or something like that. Usually, you're not doing this over HTTP. It's usually a TSP protocol or something even lower level than HTTP, but you are connecting to like a server or something like that that is listening for incoming connections from other systems, such as let's just use the word microservices for this one, right? So you have all of these amazing fancy microservices and they connect to this one single message system, and then they can send requests with different information. It can be, just a piece of text or some numbers or JSON or whatever, right? And the message that they send has what we call a topic or a subject or something of that matter. It's very similar to, you can almost think of it as a email type of deal between microservices, or from the microservices perspective, sending an email to their email provider system. And the message queue is the email provider. So you send that message with a subject or a topic or something like that. And when the queue gets that message, it stores it in a storage system. Usually it's something fairly straightforward, like it can be a file, it can be a internal database or something like that. And then what they do is that they look at the topic that you have sent as part of that message, and then they look in the subscriber bucket, because you have publishers and you have consumers, and or providers and consumers, publishers and subscribers. That's also a very common term in this pub subsystem type of deal that we're talking about here. And so the publisher sends that message, and then you look and check, okay, are there any subscribers to this specific topic, this thing that I'm looking for? If there is, then send that message to the subscribers. Now, different message queues, they work a little bit differently. Sometimes you can do like a broadcast to all of the subscribers. Sometimes you can do a broadcast to just one subscriber, or like the message that is consumed when the message has arrived to the first subscriber. There are many strategies for this. Now, in this video, we're going to use Kafka, which is just going to basically send it to all of the subscribers. So if you have multiple subscribers on the same partition, they're just going to get they're all going to get that message. But that is the basics of what a message queue does. And the reason why this is so powerful is because there are certain things that, as an example, in a microservices architecture, like the very simple one we're going to look at here, where you would like an event to be communicated to other parts of the system, but you don't necessarily want to make that part of something that is internal to the microservice itself. An example would be that if you send a message through your message queue, it could be related to something that doesn't actually need to impact the logic that you are executing right now. Now, that may sound very fancy, but I'm going to show you a use case that hopefully makes this very clear. So here is my package JSON, and I have three different types of servers here. I have a microservice for orders, books, and users. And then I have this tiny little Docker file. I've already built all of these containers, I've already spun everything up here now, as you can see here. So this is my little setup. You can ignore Mongo because I just have that running all the time, because I make so many videos about stuff that has to do with Mongo. But these are my three services: my books API, my users API, and my orders API. And here is my Kafka server. So this is the cluster. This is the Kafka server that is responsible for taking incoming requests. And Kafka depends on another Apache project called Zookeeper, that is responsible for the storage part of the system. It's basically, I'm not going to dive too deeply into what that actually means, because you can just think of it as a distributed file storage system where you're basically this is not 100% accurate, but you can think of it as just a file or a sequence of files where you append things to that file as if it was a log. It's a bit more complicated than that, but for the intents and purposes of this video, that's going to be enough. So these two need to work together. So this is the storage part, and this is the actual server that takes the incoming request, and these are my microservices. Right, so they are all working together now, or they're all wired up. And then I have my users API, which is tiny, which all it does is that it has a single endpoint that allows you to fake get a user. And then we have my books API, which is a little bit larger. And here we see that I'm depending on Kafka node, which is just, Kafka isn't node specific in any way. You can use many different types of, there are many different SDKs or client libraries that you can use in order to do this sort of thing. And here you can see that I can get a book, a fake get a book, and I'm listening on my port here and just logging out that I'm actually listening there. And then I've set up my Kafka client like this. And here I've created a consumer. And the consumer that I have created here is orders.orderPlaced. And this is just a topic can be written in many ways as long as it's alphanumeric characters. But this is what a topic is. It's just me communicating that, okay, I have this message that I'm listening on. I want to know when the orders microservice does some type of action, and this is just a convention that I am sort of fond of. Like you have a dot notation, like where you start with, it's kind of like a domain type of thing, where you start with the, I reverse it, so you start with the broadest domain, like the thing that actually did the thing, or the service, dot action, dot version, or dot something. You can just change, you can continue changing forever. And what's kind of nice about this on a more advanced topic is that you can continue this convention. So let's say that you send this message and you transform it through some type of channel into something else. Another microservice takes care of it, and then it's going to redistribute this message. Well, then you can just append it. Yeah, you can append the next microservice. So let's say that it's went to users. Okay, then you say users dot did thing, and then you distribute that, and then you can actually chain. It becomes like a selector or a domain DNS type of thing. It's up. I'm rambling now, but it's just something that I like doing. And then we have two listeners here. We have an error listener. Hopefully we're not going to have to use that. And then we have a message listener. And this is the part where when we're listening to this thing, this is where the message is actually going to hit us. Now, we're not performing any domain logic based on this, but you can just, for the sake of argument, imagine that, okay, so I'm listing on orders.ordersPlaced, and then this message comes in, and then I now know that, oh, okay, there was an order here. Okay, cool. Then let me check which book was part of this order that was placed, because I have in my internal business logic, I want to add a certain amount of stars, or like a rating, or like a frequency, like which books are very popular and which books are not so popular. And I don't want to have an endpoint here for some external system to tell me that, because that's just inefficient. I want this to be asynchronous. I just want this to be something that happens without impacting the logic of, say, my orders microservice or something like that, because it's not so important that this happens directly. And that's the key thing I want you to take away from a message queue. Well, this is the strong use case. A message queue is a perfect thing to use when you have an action or an event that doesn't have to finish at the exact moment of when the incoming request comes from the browser or the client or something like that. Some things needs to happen immediately, like as an example, if I ask for a book on my API, well, then I kind of have to return that book as part of this request, because it becomes really weird if I don't do that, because then the other part would have to say, oh, okay, I want a book, and then they have to have an endpoint on their side, and I go, oh, okay, I will send you the book or the information regarding this book at some point. Usually it's microsecond, like milliseconds or something like that, or a few seconds, but it's much better if we just use the HTTP protocol in this scenario. And for this thing that kind of doesn't have to, I mean, because we don't really care. Like, we just want to know that the order was placed. We don't care if it happens immediately. We just need to know, right? And this scales so gosh darn well. Like, I absolutely love. I mean, if you are doing microservices, this is for sure something that you should be leveraging. It is. I just love it. I absolutely love it. And this is my orders service. And here you can see that I have a client, and this time I'm creating a producer. And this producer is just going to publish to a specific topic, like the same topic here, orders placed. And then here we have my little endpoint. And this is where like this microservice type of thing kind of comes in, where, all right, so the order service is going to contact the user service, and we're just faking here that, oh, we're getting a user, because we don't have a session, and we don't have any token or anything like that. So this is just for pretend. It's just pretending, but it's very similar to what the reality was going to look like. And then we're getting a book that is part of this incoming request here, so because we're sending a book ID and a user ID, and this is the user who wants to buy that book. And then we create our order, which is just a snapshot of the user and the book, because we don't want to use IDs when we're creating an order, because if we just have an ID, then maybe the user changes while we're placing the order or the book or something like that, and we just want a snapshot of what the state of the system, or the state of the user and the state of the book was at the moment of placing the order. And then we send the message. So we create a topic, put that in an array, because we can distribute multiple topics or multiple messages, and then we send our messages. It can be an array. In this case, it can be an array or a string, and I'm just keeping this as a JSON string here. And then we dispatch it. And here we just have a ready listener and an error listener, so we know when it's actually safe to send all of these messages. And that's pretty much the whole deal. So the basic architecture here is very simple. This is the thing that a browser or some other service is going to, or some client is going to connect to and say, hey, I want to place an order here. And the thing that needs to happen here is basically that the order is sent back immediately as part of this request, but we also want to dispatch the event. This is the thing that is key here. Like, we don't want, because we could very easily have added an endpoint here for, say, the books API, and say, okay, adding an endpoint here stating that, oh, you just report to me that this book has seen an order. And that's absolutely feasible. You can do that, but it's not going to scale as well when you get quite a lot of these services, because imagine if there was another service, I don't know, a special new API here that also needs to know that there was an order. And then you have to add another endpoint here, and then another one, and then there's a fourth service and a fifth service, and it kind of just goes from there. And you have to now go to each of these. You will have to make one network request to all of these different services just to report that, oh, this order here was placed. So this is a very efficient way to just scale that information distribution system, where I just make a single message request to the Kafka server, and that server now holds all of the information. Like, the event has been published, and everybody else can just get informed whenever they want, right? Or whenever that's needed. Usually it's pretty much in real time. However, let's take a look at how this actually works. So if I say docker log/f and I say books, was it right? Yes. So here I have an example of a message where I pretty much just, well, this is a log of that message I was talking about. So if I do, let's say I do a curl here, because I think I still have that. Yes. So this is a little bit of I'll walk you through this. So I'm just gonna use Docker to do this. So I'm going to execute an interactive terminal in the orders container, and then I'm gonna curl the orders API endpoint, which is this endpoint here, right here. And then I'm going to post to that endpoint with a application JSON request, and then I'm going to pass in book, like a JSON string here, book ID 1 and user ID 1, exactly as kind of in line with this. And if I just do that, it's going to return to me the order that I just placed, and you will notice that up here there is now a new message. And that's exactly what I wanted. So what just happened is that I sent this request to this endpoint. This code executed, so I connected to the users API, the books API, I got all that information, created an order, posted the message to Kafka, and then I responded with the finished order. And this is what Kafka did. So Kafka now took this information into its storage system, and it dispatched this message to all of the listeners. And in this case, the only listener we have is the books API, but we can append as many as we want. And you'll notice here that the first message had an offset of 31, and the second has an offset of 32. And if I continue doing this, you'll see that it's 33, it's 34, it kind of just continues, and that's exactly what it's doing. It's appending new messages. So if I go to the storage system and I inspect it, you'll see, there will be one new entry for every message that I send that is going to contain this information that you see here. And the offset is just, you can, for simplicity's sake, just think of the offset as an ID, an identifier. It's an append-only identifier. And that's pretty much it. So what I want you to take away from this is that message queues are just a service like any server that takes care of taking an incoming message, you can think of it as an email between different services. It takes that message and is responsible for distributing that message to a bunch of other services that are interested in knowing that this thing actually happened. This is perfect for when you do something like this, where you need to communicate that, oh, there was an order that was placed or something like that, something that doesn't have to be part of the logic that is part of the incoming request like this. Things such as, you may have thought about it yourself, that sometimes when you send an email, it doesn't get dispatched immediately, or you don't receive it immediately. That's because of quite a lot of these email services or email clients that you use actually use a message type of system where they batch sending out emails in a very similar fashion to this. They simply say that, oh, we need to dispatch this message. Can you process it whenever you have a moment to do that? And the receiving system that is actually responsible for sending out that email does it. And that's a very, very, very useful case for a message queue. Or when you want to get some metrics or something like that, this is a perfect use case. So hopefully this has helped you understand what a message queue is and what you can use them for. Have a great day.